Today's topic, planetary tilt. It looks random, but it's not. In this video, we're going to discuss how planets are formed, the basics at least, how planetary dynamos work, the basics at least, and finally how to predict planetary tilt. Now, if you're a big fan of astronomy, you probably already know the basics of how a planet is formed. We'll start with a cloud of dust swirling around a star. Well, the dust collects into larger and larger pieces, and we can see here, if we look, we have some rocks going. I'll point to one here. So these rocks get bigger and bigger, and they collect together, and eventually you get a planet, or at least the beginnings of a planet. And this planet is still, of course, rotating the way it was formed in the same plane, and with no axial tilt to the star, because everything's swirling in a circle. And if we're lucky enough, we'll get water and a beautiful planet like Earth. So since all the planets formed from the same swirling ball of gas, they should all be upright, but they're not. As you can see, they're tilted all over the place. I'll highlight it for you. Now, most people think this is random. It's not. It's actually easily predictable, and we're going to look at why. But before we get started, let's talk a little bit about asteroids and why they're not the ones that are knocking the planets over. Well, when a planet is spinning, it acts like a gyroscope and is very resistant to being knocked over. I'll put some links about gyroscopes in the description. But if we look at other planets like the Moon and like Mercury, we can see they're both heavily impacted, and yet they have no axial tilt because they're both spinning like gyroscopes. And you can see all the craters, but neither one is tilted to the side. So if you want to use that as an excuse for the other planets, it doesn't even work for the small ones that have massive impact. So we don't think that's how it works. Let's talk about dynamos. If you've taken any basics physics, you know that a dynamo is basically a spinning metal, in this case copper wire, between a magnetic field, and it creates electricity. It's all motors do the same thing. It's a very basic idea. A copper wire spinning with a magnetic field creates electricity. So magnetic field is converted to electricity. We see it all the time in almost everything we do every day that has an engine. Planets actually work the same way. We can see here that there is an inner core, that's a heavy metal core. It's spinning, and there's an outer core, and boom, it's creating a magnetic field. So planets work very, very similar to engines. Spinning metal creates a magnetic field. Now, why does it need a magnetic field? Well, here we go. We have the sun. Solar wind, which is charged particles, electricity, radiation, basically blasts the planets, and it blows away all their atmosphere. Now, I don't know about you, but I like atmosphere. Now, here's a better example. Here's the Earth's magnetic field protecting us from the sun's solar wind. And this solar wind, again, can get rid of the atmosphere. So the magnetic field is important. Thus, the dynamo is very important for life on Earth. Now, if we look at the motor again, normally you would have some sort of force like water turbines creating electricity, but you can actually reverse it. Electricity comes in, charges the magnetic field, turns the turbines. There you go. You have a basic motor. So if planets work like this, what happens if it's not quite big enough dynamo? How does it charge the dynamo? Well, we have to look at the Avengers for the answer. Here we see Thor. He's charging up. He launches at Iron Man. Iron Man's dynamo's charged. You can see 400%, and allows Iron Man to do this. So, electricity charged the dynamo, gave him more power, and boom, he knocked Thor back. So, just to reiterate, if we look at a planet and the sun, the pole is where you would charge a planet, and the side, the magnetic field on the side, is what deflects the solar wind. So it's very important. It's very important to have this deflection of the solar wind, otherwise we have no atmosphere, but it's also very important to charge the dynamo to keep that solar wind at bay. So what does this have to do with planetary tilt, you ask? Good question. Well, we have to make a little assumption. We have to assume that the planets want to keep their gas too. And so Because the planets want to keep their gas, they're going to do everything they can to charge their dynamos to protect the gas. So that's the basic assumption we're going to make. And in order to change the dynamos, they basically have to point their pole towards the sun. So the smaller the core, the more the tilt. The bigger the core, the less the tilt. Here's an example using Earth. So the core is not quite big enough to make a magnetic field to protect everybody. But as it tilts, the magnetic field gets longer, or bigger I should say, and now it's able to protect itself from the wind from the sun, the solar wind. And the atmosphere stays with the planet. So a basic hypothesis can be, if a planet has gas to protect, it will orient its axis towards the sun to recharge its magnetic field based on the strength of the magnetic field generated by the planet's core. So again, if we look at Iron Man, Thor, charging up, same thing with the planets. So we're going to have to ask a couple of questions. Question number 1, does or did the planet have gas to protect using an electromagnetic field? Meaning, does it have some reason to extend its magnetic field? And the question number 2, if yes, what is the size of the magnetic field generated in the core? How big is the core? And finally, once we know that, we can say, hey, we think we know what the axial tilt is. So let's start looking at some planets and see how this works out. We'll start with Mercury. It's the first planet. It's fun. It's tiny. All right, beautiful Mercury. Here we go. Does it or did it have a gas to protect with an EMF? What is the strength and magnetic field generated in the core? And what's the theorized axial tilt? So, does it have or did it have gas? No. What is the strength and magnetic field generated in the core? Well, the core is small, but it doesn't matter because, again, it doesn't have gas to protect. And finally, then that means the axial tilt? Well, it should be basically none. Because there's no gas to protect, it doesn't need to maximize its magnetic field. So let's see, and ding, there you go. No axial tilt at all. Good start so far. Okay, our next planet is Earth. We're actually going to skip Venus because Venus is a little weird. We'll come back to that in a minute. So let's look at Earth. So let's bring up the questions again. So does it have gas? Well, yes, it does. I'm very fond of the gas it has. What is the strength of the magnetic field? Moderate. You're going to see that a lot. So we're going to call that 20 to 30%. I meant degrees out of 180 degrees. Moderate, I don't know what else to really do. So 20-30% sounds pretty good. And ding, 23%. So looks pretty good so far. Now if I'm keeping track, that means so far I'm 2 out of 2. All right, next planet. Mars, beautiful, small, tragic Mars. All right, let's look at these 3 questions again. Again, does it have a gas to protect? Well, believe it or not, it did about 1 billion years ago. And this is actually good through time. So 1 billion years ago, it actually had gas like Earth. And the core, well, the core is actually similar size to Earth. So the tilt should be very similar to Earth. And if you remember, Earth's tilt was 23%, so let's see here. Mars is, ding, 25%. Okay, not bad so far. So, a moderate tilt just like Earth. All right, looks like we're at 3 out of 3 now. Jupiter. Jupiter's next. Jupiter is the big guy, the first gas giant in our system. Does it have gas to protect? Well, yes, actually it has a bit more than a little to protect. And is it magnetic field? The core is huge. It's actually the second largest magnetic field, so it's strong like an ox. And that means, well, it doesn't really need anything from the sun. So no axial tilt because it's got a strong core. And survey says, well, let's just say ding and no tilt. So it doesn't need anything from the sun. All right, well, let's look here. It looks like I'm 4 out of 4. Next planet looks to be Saturn. Beautiful Saturn. All right, Saturn, let's bring you up here. There you are with your beautiful rings. Believe it or not, we'll talk about those rings in the next video. Now, how much gas does it have? Well, believe it or not, it actually has an unimaginable amount. You have no frame of reference for it or Jupiter. Neither do I. It's so much gas. Now, its core is, again, moderate to the size of the planet. So if it's moderate, that means we need a 20 to 30% axial tilt. Moderate. That's such an odd word. But ding, It looks to be like it's a moderate tilt so far. All right, well, that was Saturn, and there we are, 5 out of 5. Next planet looks to be Uranus. Uranus is special. It's our first gas giant, or I'm sorry, our first ice giant in the system. And it has a rather surprising amount of gas, no doubt. But what you might not know is it has no core. Its core is pretty much gone. So that would mean that it has no way to generate electrical field. Well, that would mean the axial tilt would basically be on its side. It would have to have the full money be fully exposed to the sun. Give it to me, baby. And ding. Well, it looks like that's exactly what we're seeing right there. Almost 100 degrees towards the sun. All right. Well, 6 out of 6. Next is Neptune. Beautiful Neptune. The last planet in our solar system, even though Pluto's there, it's not really a planet yet. Neptune, yep, as always, there's 3 questions. Does it have any gas? Yes, it has a rather significant amount of gas. What's the size of its core? Well, there's that weird word again, moderate. And again, what does that mean? Axial tilt 20 to 30%. Earth 25, Mars is 23, Saturn's 27, so ding, 28 degrees. All right. And let's see here. If we look back at our planets, that's right, I'm keeping score, 7 out of 7. And the next planet is Pluto. Now, you guys can call me Jerry all you want. I think Pluto's awesome and should be a planet again. But anyways, I digress. I'll just take half a point if I'm correct. We'll call that even then. All right, does it have gas? Yes, shockingly it does. What is the core? Well, we believe it to be really small. So if it's an ice planet and it has a really small core, well, it's going to be really similar to Uranus. Basically, well, not quite on its side, maybe a little less shy about how much it gets from the sun, but still, it's the only thing I can think of. And ding, there we go. 120 degrees and Uranus's was 90, so a little bit less shy about it. And that puts me at 7.5 out of 7.5, because, Pluto, not a full planet, and brings us to Venus. Venus is really, really weird. Why? Well, if you know anything about it, it's really close to the sun, and yet it does have gas to protect. It has actually a significant gas, but it doesn't need an EMF. Why? Well, the gas is not being blown away. It has no magnetic field. And yet the gas is not being blown away. I have no idea. But it's still, that means I would still have to say the core has, or there's no axial tilt. So the core, even though it's really tiny, it should still not be tilted because it doesn't need anything from the sun. And if we survey says, or if we do ding, there we go. It's almost upright, but it's actually upside down and rotating backwards. So technically I'm still correct. I just feel a little uncomfortable about it. So I'm going to give myself 8.5, but on a technicality. All because of Venus. But it still fits. It's just a weird planet. All right. So today we discuss the basics of planetary formation. From clouds of dust, they collect into larger rocks, but they should all still be, when they formed, have zero axial tilt. They should all be spinning in line with the sun, but they're not. We also learned today that planets have dynamos inside of them, and we learned how you can remote charge a dynamo. You don't need Thor to do it, but that was a good example. And we learned that dynamos are important to protect the planet's gas from being blown away. As we can see here, that the sun can also charge the magnetic field, keeping the gas from being blown away. And we learned finally how to predict axial tilt. So, I hope you enjoyed this video, and subscribe and like.